All right, so my goal here is to demonstrate conservation of momentum with various collisions. So to start off, I have the Velcro sides of the carts facing each other. So these are going to be totally inelastic collisions. They're going to stick together. This would be, in real life, this would be like one person tackling another. The carts have equal masses, so right now, what I'm going to do for my first collision is I'm going to push the red car into the blue car, then they're going to stick together. So after they stick together, essentially the amount of mass that's moving will double, so the velocity should be cut in half. Now I'm not going to actually measure the velocities, but you can kind of visualize it. All right, so after they stick together, they move with half the speed that the red car had. All right, now I'm going to do this. I'm going to double the mass of the blue car. So this means after they stick together, the amount of mass that's moving will triple. And the new velocity is 1/3 the velocity of the red car. Sure, right? We don't have to measure it. We can see that. I'm going to make the mass of the blue car 3 times the mass of the red car. So after they stick together, the mass that's moving will quadruple, and the new velocity of both cars together is 1/4 the velocity of the red car. Now I could also do it this way. So the red car has twice the mass of the blue car. So now after they stick together, the mass will only increase by 50%. Or in other words, after they stick together, the new mass will be 3/2 what it was before, so the new velocity would be 2/3 of what it was before. If I do it this way, the red car has triple the mass of the blue car. So after they stick together, the new mass is 4/3 the mass of the red car, so the new velocity would be 3/4. All right, so in other words, it doesn't slow down a whole lot, but it does slow down. Okay, so those are totally elastic. We can also show that with, those were totally inelastic. We can also show that with elastic, meaning they totally bounce off of each other. I'm going to push the red car into the blue car again. All right, now there's some friction, so things are slowing down, but essentially, this first one, the red car stops, and the blue car takes off at the same speed that the red car had. If I double the mass of the red car, the blue car essentially takes off at twice the speed of the red car. If instead I double the mass of the blue car, it'll take off at half the speed of the red car. Okay, so that's conservation of momentum. Now in reality, totally elastic collisions are rare, and totally inelastic collisions are rare. Most collisions are somewhere in between. There's some bounciness, some stickiness, but it doesn't matter. Momentum is always conserved in every single collision.